Hey everybody, in this video I'm going to be reflowing not one, not two, but three nVidia GeForce based motherboards. These have the GeForce 6100 or 6150 LE chipset, and all three of these boards will not post anymore. This is a common symptom with newer motherboards with nVidia chipsets that have ROHS compliant lead-free solder on them. The lead-free solder gets cracked, little bitty cracks, and what happens is the chipset loses connection with the motherboard, so the motherboard appears to be dead. I've done this quite a few times in the past, and sometimes everything works just fine. Other times the board would die after a few weeks or so. But if you guys look on my channel, you'll see I reflowed an eMachine's motherboard probably about 2 or 3 years ago. And that motherboard has been in service for over a year now, working just fine. So it's really hit or miss. So basically this is something you can do if your motherboard is no longer working and it has the nVidia GeForce chipset. So anyways, let's go ahead and get started. First thing to do is take any heat sinks off of the northbridge chips. That way you have access to the actual chip itself. And basically the way this works is you preheat the board with a you use a heat gun in the whole process. And what you do is you preheat the board for like a minute or so on low, and then you use a 10-volt thing like this to direct heat away from components that don't need it, and only allow heat on the device you're trying to heat up. And what this does is this heat pretty much does exactly what the procedure says. It does a reflow of the solder, so that way the connections are reseated and everything like that. So that being said, let's go ahead and get started. So first what I'm going to do is I'm going to do the board down at the far end. That is a all three of these boards are actually from HPs or compacts, manufactured by Asus, and this one is a socket 939. So that being said, we'll go ahead and take this off for the moment. Time in, plug in our heat gun and do a 1 minute preheat. Okay, board is nice and warm, but not extremely hot. Notice how I was able to hold it and everything. We're going to place our aluminum foil shield here and begin the procedure of actually doing the reflow. In this case, we'll be having to run the heat gun on high, so we'll be having a lot more heat here. This is where I got to be careful. Do a readjustment here so you can see exactly what I'm doing. The reason I have to be very careful on this board is because we got two capacitors right near where we're working. And obviously these capacitors are rated for like 105 degrees Celsius operating temperature max. So we need to be careful with those. Don't want to overheat them, otherwise I have to replace them. That's just more work you'd have to do to try to avoid it. Now, of course, I'm guesstimating my time because I don't have a clock out here. I got a little timer on the camera, but I can't see the LCD display from here. Try to make my aluminum foil stay put. I think we're good to go. So anyways, here we go. We're doing this for about 4 minutes. Alrighty, that one's cooled down a little bit. It's going to need to sit for probably 15 to 20 minutes. So here's a look at it. Nothing unusual, just too hot to touch right now. But basically what this procedure has done is it has reflowed the solder on this motherboard right under the chipset, Northbridge chip. So anyways, I'll be doing a test on these motherboards to find out if they work or not afterwards. In some cases, it could be other reasons why they don't work, but reflowing is always something to try. So there's the other two boards. Now I'll go ahead and start on this one. I'll place the camera in a different spot this time, so you can probably see a little bit better. And that way I can view the clock on the camera as a source of time to go by. Set this motherboard on my hand to the side so it can cool off. Okay, now we'll start on this one. This one right here. This is a socket AM2. Actually, both these here are socket AM2s. This one here is fully loaded. This one here is more of a basic end. They're the same boards, but this one here has more features. This is HP's. This one here is HP's budget-in AM2 board, and this one here is their higher quality board. These are both A8 M2N-LA boards. And I find these boards to be great for refurbished computers. They're easy to set up. They have good graphics and that kind of stuff. So let's go ahead and switch on the low for a minute. Okay, it's been around a minute or so. So I'll go ahead and flip the board back over and insert the aluminum foil cup I have to protect the remaining parts of the board. I gotta spin the sink to the side so I can angle the heat gun toward this direction to try not to overheat a neighboring capacitor. Similar to the previous board. We're going to go back to high for 4 minutes. And cool it down a little bit. Got the heat gun set on low. Going to remove our aluminum foil. Make sure this poor capacitor didn't get overheated. It's not bulging. That has happened one time when reflowing. I had to replace one capacitor because I overheated it. But anyways, there is this board. Nice and toasty. Gotta let it cool down some. These boards get hot enough to flex when doing these reflow procedures. If you look carefully at my first reflow video with the E-Machines motherboard, you will clearly see the board flex because I had it up at an angle. The entire motherboard flexed. So anyways, here's our final board. There's 3 here to reflow. That one there, if you haven't seen it yet, I tried to replace the audio jack on it, but that was kind of an epic fail. The board still works, but it will no longer have onboard audio. The reason why is traces got pulled loose, and there's nothing I can do about that. But anyways, back over to here. Go ahead and do this motherboard, and here is a stink bug. Okay, here's our last board. It's a budget model, as I mentioned earlier. Has less DIMM slots for memory, has basic audio. Those are really the only 2 differences between the 2. Oh yeah, and this one has less SATA ports than this one. Go ahead and do the 1-minute warm-up on this one. I'll actually have the camera facing the other direction like the previous one, so I can see the clock. Here's our 1-minute warm-up procedure. Okay, it probably wasn't a perfect minute because I wasn't paying enough attention to the clock on my camera. Anyways, I'll go ahead and place the aluminum foil protector on here. Place a board just like this, like I had the previous two. Okay, there's our aluminum foil cup to deflect heat off of other components. Go ahead and start the reflow procedure. Alrighty, now it's gotta let this one cool off. And then what I'll do is I'll reattach some heat sinks to these northbridge chips and test these motherboards. See, this is, so here's motherboard number 1. This is motherboard number 2. And that's motherboard number 3. And nearby capacitor looks okay. The sleeving looks like it got a little warm, but the cap's not bulging, so we're good to go there. So anyways, let's see how this goes. Okay, first board up for testing is board number 3. Since I already had the CPU bracket already installed, we installed a heatsink, some test memory, CMOS battery, power button, and let's see how it works, if it works. Truth is, I already tested it, so see for yourself. Works just fine. Okay, that's board number 1. Board number 3 from the video earlier today. Next I'll be testing board number 2. Turn off this power supply and discharge. Now all I gotta do is swap out the CPU and cooler for this board, add a retention bracket, add a heatsink, battery, and swap the memory over and test this one, see if it works. Okay, I got motherboard number 2 plugged in, and you see it's running. So you're thinking, oh, there's nothing wrong with that board, it's working fine. Well, there's actually an issue with it. Look carefully. You see that jumper right there on the ATX power connector? That is the only way to make this thing even run. The power button does work. You see the monitor went blank and the fan on the motherboard actually stopped. But of course this LED here is still lit because power supply is still running due to the jumper. This motherboard appears to have an issue with sending a power on signal to the power supply. You see it boots right up when I got the thing jumpered. Boots right up when the power supply on. Green wires jumpered to ground. Apparently I'm guessing there is a transistor fried on this board that is responsible for sending, you know, this signal to ground. That's all I can really think of. Just have a look. I'll pull this jumper out and it just cuts right off. Press this power button all I want. Motherboard's probably trying to power up, but it can't send a signal to the power supply to come on. It's very unfortunate, I must say, that something as simple as that prevents this board from working. This would be a pretty nice board if it worked. As you see, I'm pressing and pressing and pressing and pressing, but nothing happens unless I jumper the PS on to ground. See, it boots right up and I pull the jumper out and it just cuts right off. What a shame. This is the same problem this board originally had when I got it, though I never realized that jumpering power supply would actually make it power on. So I'm not sure if it would be an issue with the south bridge itself, or, like I mentioned earlier, a transistor of some sort that sends the power on signal to ground. Beats me. Anyways, on to the next board. It's very unfortunate. Okay, I got the third board up here, which I believe I call board number 1. This one here is doing the opposite of what the previous board did. The previous board worked with the exception of being able to turn on the power supply. This one turns on the power supply but does nothing. Doesn't even spin the CPU fan. So a complete opposite of the previous. It does light the power LED but no hard drive LED. Isn't that just amazing? I believe these last two motherboards had issues other than the Northbridge chip, like I had suspected earlier in this video. These boards had been sitting in that box over there for probably months to a year, if not more. So it's been quite a while since I worked with these, so I wasn't really sure exactly what the problem was. I just assumed that the Northbridge had failed. But anyways, we did manage to rescue one board. It's that one right there. Works just fine. I'll be using it. So anyways, had no questions or comments. Feel free to ask, and thanks for watching.